All right, derivatives. Who uses this stuff, right? Business example. So if we have a function, c of x, and that is the cost to produce x items, then what the derivative means is how the cost changes to produce one more item. So for example, like if you had c prime of 11, then that would be the additional cost to produce the next item, the 12th item, after you've already produced 11. So let's look at an actual example. So if I have this function, f of x equals x squared minus 100x, and this just happens to be an equation which it's the cost in producing x laptops. You can call it c of x if you like. So this is the cost of producing x laptops. So x, the number of laptops. And what if we want to know at what point, okay, where 200 computers have been produced, what would the approximate cost be of producing the 200 first? So in other words, what we're looking for is f prime of 200, and then this would be the cost of producing one more to get to 201. So as soon as I see f prime, I'm thinking, oh, I bet I'm going to have to find a derivative, which is my limit as h goes to 0 of where I see x, I'm going to put x plus h. Where I see x, I'm going to put x plus h. And then where I see x, I'm going to put x. And where I see x, I'm going to put x. And all of this over h. So once again, hopefully you are getting this down, why you need this repetition, working these, that's the formula to find the derivative. So now algebra we go. So I can FOIL the x plus h, which would become x squared plus 2xh plus h squared. I can distribute the negative 100 h. Why not? Let's go ahead and distribute this negative x squared and a negative plus 100x. And all of this is over h. Well, as we've talked about, things that don't have an h, guess what? Disappear. If it didn't, ruh-roh, we have a problem. Then we have to go back and check our algebra, okay, to see what might have happened. All right, so still on the way, getting this limit. I have 2xh plus h squared minus 100h, right? All I'm doing is getting the leftovers all over h. Still can't let h go to 0 because bad things will happen. So why not factor out an h up top, which leaves me this piece right here. And if I can get my colors to go, that cancels. And so I'm simply left with the limit of 2x plus h minus 100 as h goes to 0. Bye-bye. You went to 0. And so I get my f prime of x then is going to equal 2x minus 100. So this is my function that now I can plug in any value, okay, in this case. And what we asked for was f prime of 200. So if I plug in 200, then it looks like I am going to plug in 200. 2 times 200, 400, minus 100, 300, which would be the approximate cost of producing one more item. So you're going to see derivatives are very, very much in applications. It's just understanding what a problem is asking you that you do understand that this was a derivative.